Ladies and gentlemen, once again you are welcome to Communal Priority channel. In today's video, we will discuss some example of chain rule. Please don't forget to like and subscribe this channel for more videos. So let's get started. Number one, we said if u is equal to open bracket 1 minus 2xy plus y square of minus 1 all over 2. So first of all, show x du over dx minus y du over dy is equals to y square u cube. So solution. First of all, we'll differentiate our value, and don't forget it's a chain rule of differentiation. Therefore, this will be du over dx. Our differentiation of u in respect to x, that is, will be equal to minus 1 all over 2 multiplied by the coefficient of the bracket, which is what? Which is 1. Therefore, this will be minus 1 over 2 multiplied by the bracket as it is, open bracket 1 minus 2xy plus y square to the power of minus 1 over 2 minus 1. Since it is differentiation, we are always subtracting 1 from the power. Then multiply by the differentiation of these brackets, which will be what? Du over dx of the bracket of 1 minus 2xy plus y square, cross bracket. First of all, we'll multiply this 1 over 2 with the coefficient of the bracket, which is the rule of differentiation, will give us minus 1 over 2 open bracket 1 minus 2xy plus y square to the power of minus 1 over 2. Then we'll subtract 1 as a rule of differentiation. We saw different types of differentiation in our previous video. You can search in our YouTube channel. So when we multiply this our coefficient, this our power with the coefficient, we got to minus 1 over 2, and we subtract 1 from the power. Then multiply by differentiation of this bracket, only this bracket. Multiply will differentiate in respect to what? In respect to x. Therefore, now our du over dx will be equal to minus 1 over 2 into 1 minus 2xy plus y square to the power of minus 1 over 2 minus 1. It's very simple. First of all, we'll bring it here. Let's do it here. Minus 1 over 2 minus 1. Just add 1 here to take the LCM, because even if you divide this with 1, it's the same thing as you have, because 1 divided by 1 is equals to 1. So we'll just add 1 here in order to find it easy in taking their LCM. So the LCM of 2 and 1 is what? Is 2. How many times can 2 go into 2? Is 1 time. 1 multiplied by 1 will give us minus 1, because we have minus here. Will give us minus 1. Then put your minus down. How many times can 1 go into 2? 2 times. 2 times 1 will still give us 1. Therefore, this will be minus 3 all over 2. So therefore, this will be power of minus 3 all over 2 multiplied by differentiation of this value in respect to x. First of all, differentiation of 1 in respect to x is 0. And again, differentiation of y square in respect to x is also 0. Because if you are differentiating in respect to x, anything that is not attached to x will be 0. Therefore, this 1 is 0. And also this y square also is 0. We are going to only differentiate this 2xy. And differentiation of minus 2xy in respect to x is minus 2xy. First of all, if we differentiate this x, we are getting 1. Because x to the power of 1 minus 1, which is equal to x to the power of 0, which is equal to 1. So therefore, this will be 2 minus 2 multiplied by 1 multiplied by y. Then y multiplied by 1 multiplied by y will be what? Will be y. Therefore, this will be minus 2y as our differentiation. So then this will be multiplied by minus 2y, close bracket. Our du over dx now will be equals to minus 1 all over 2 into 1 minus 2xy plus y square to the power of minus 3 all over 2. Now we can factor this minus 2 out. Multiply by minus 2, open bracket y. Because minus 2 multiplied by y will give you back as we have minus 2y. So therefore, you can just factor it out without any problem. So therefore, this minus 2 will cancel this. So let me use the red pen. This minus 2 will cancel this 2 and this minus 2. Therefore, this minus cancel this minus, this 2 cancel this 2. And now we are left with du over dx will be equal to, this is the same thing as 1, open bracket 1 minus 2xy plus y square to the power of minus 3 all over 2 multiplied by what? Multiplied by y. This y will multiply by this one to be what? Du over dx is equals to y multiplied by 1 will be what? Y, open bracket 1 minus 2xy plus y square to the power of minus 3 all over 2. So therefore, now we said in the equation x multiplied by du over dx. Therefore, we are going to multiply this question with what? With x, since we are differentiating in respect to x. So now we'll multiply our equation through by x. Therefore, this will be x du over dx will be equal to x multiplied by whole of this value will be xy, open bracket 1 minus 2xy plus y square to the power of minus 3 all over 2. The reason why we got this x is because we multiply all our equation with this x. Therefore, x will multiply the whole of this equation. So therefore, we'll take this as our equation 1. Then now we are going to equation 2. Sorry, let me use the red pen so that I will not be confused. Equation 1. So now let's move for the 2. Now, du over dy will differentiate our this equation in respect to what? In respect to y. Since we have done differentiating in respect to x, now we'll differentiate it in respect to y. So therefore, this will be equal to, as we did before, first of all, the coefficients will multiply, the power will multiply the coefficient. And we say our coefficient is determined as 1, and our power is minus 1 all over 2. So therefore, this will be minus 1 all over 2, multiply the whole bracket, which is 1 minus 2xy plus y square to the power of minus 1 over 2 minus 1, right? Because we are always subtracting 1 from the what? From the power. So multiply by what? Multiply by the differentiation of only this bracket, which will be what? Du over dy now in respect to y, not in respect to x. Open bracket 1 minus 2xy plus y square to close bracket. So therefore, our now du over dy will be equal to minus 1 all over 2, open bracket 1 minus 2xy plus y square, close bracket. We said minus 1 over 2 minus 1 is the same thing as minus 3 over 2, but let's prove it here. Minus 1 over 2 minus 1. We can add 1 here, because anything divided by 1 is equal to that number. So therefore, this will be LCM of 2 and 1 is what? Is 2. How many times can 2 go into 2? 1. 1 times this 1 will give us 1. Therefore, we can put our minus 1. Then minus. How many times can 1 go into 2? Is 2 times. 2 times 1 will give us 2. Therefore, minus 1 minus 2 will give us minus 3 over 2. So we can put our minus 3 all over 2 here, multiply by differentiation of this bracket in respect to y. Therefore, first of all, differentiation of 1 in respect to y will give us 0. Again, differentiation of this value in respect to y will be, differentiation of y is already 1. So, just like we did before, 2xy. The 2x will be constant. Differentiation of y will give us 1. Therefore, it's equals to minus 2x. So, this will be minus 2x plus. Differentiation of y square will give us 2y. Y square, 2 times 1 will give us 2. Future y, 2 minus 1. Therefore, this will be 2y to the power of 1, which is the same thing as just 2y. So therefore, this will be 2y, close bracket. So now our du over dy will be equal to what? Will be equals to 1 minus 1 over 2, open bracket 1 minus 2xy plus y square to the power of minus 3 all over 2. 2 and 2 here are common. So you can factor them out. You can just say minus 2, open bracket x minus y. Because minus 2 multiplied by x, you will have minus 2x. Minus 2 multiplied by minus y will give us plus 2y. So we can just factor the 2 out, it's normal. So now this our minus 2. This our minus 2 will cancel this minus and this 2. So therefore, this 2 and minus cancel this 2 and this minus. So therefore, now we are left with du over dy will be equal to, open bracket 1 minus 2xy plus y square, close bracket, then open another x minus y, close bracket, because this 2 and this y cancel this 2 and this y. So we can just bring this our bracket here because it's normal. Multiplication are commutative. So therefore, this will be du over dy. This is u. Du over dy will be equal to x minus y, close bracket, of another 1 minus 2xy plus y square to the power of 3 over 2 to the power of minus 3 over 2. So now we can simply multiply through by y as we said in the question. y multiplied by du over dy. Since now we got our du over dy, we can multiply our equation to rule by what? To rule by u. So this will be, sorry, let's use another paper. Don't forget our du over dy we said is equal to x minus y close bracket open another 1 minus 2xy plus y square to the power of minus 3 all over 2. And we say we'll multiply to rule by what? To rule by y. So therefore now y multiplied by du over dy will be equal to y open bracket x minus y close bracket open another 1 minus 2xy plus y square to the power of minus 3 all over 2. So we call this as our equation 2, sorry. So now since we say, in question we say prove x du over dx minus y du over dy is equals to, we say it's equals to y square u cube. Now we're going to multiply, we're going to subtract our x du and x du over dx and y du over dy. But don't forget, we say our x du over dx is this. This is our x du over dx. So therefore, this will be what? X, y, open bracket, right? We have x, we have y, open bracket, 1 minus 2xy plus y square to the power of minus 3 all over 2. Which is what? Which is x over du. Then minus, now we'll bring our y over du, which is what? Which is this one. Which is this one. Y du over dy will be what? Minus, open bracket, x minus y, close bracket, open another 1 minus 2xy plus y square to the power of minus 3 over 2. So if you see clearly, y, open bracket, 1 minus 2x plus, sorry, y, open bracket, 1 minus 2xy plus y square and y 1 minus 2xy plus y square are common from both sides. We have it here. Let me use the rest here. We have it here, and we also have y here, and we have it the same thing here. So we can just factor them out. This will be written as y open bracket 1 minus 2xy plus y square to the power of minus 3 all over 2 into our x minus open bracket x minus y. Because if we multiply this y open bracket 1 minus 2xy plus y square to the power of minus 3 over 2 multiplied by x will give us this one. If we multiply this value, the whole of this value and x, it will give us xy 1 minus 2xy plus y square to the power of minus 3 over 2. Again, if you multiply this y with this minus, note that this x and this minus y like this are different value. This is one and this is other one. So therefore, if we will multiply this equation with this x will give us this one. And again, if we will multiply this equation with this minus open bracket x minus y will give us as we have in this side. So therefore, we can write this one. They are all the same. So therefore now, this x will cancel this x, right? This x will cancel this x, and minus times minus will give us plus. So therefore, now our y open bracket 1 minus 2xy plus y square to the power of minus 3 all over 2. Since this x cancel this x, minus times minus will get plus. This will be what? Plus y, right? So therefore, we can say y multiplied by y will give us what? Y square. Don't forget, we are subtracting dx minus du over dx minus, we have x du over dx minus y du over dy. We are subtracting this value, so don't forget. So therefore now, our x du over dx minus y du over dy will be equal to, we say this is positive y and this is positive y. Then this will be y times y will give us what? Y square. This will be y square into open bracket 1 minus 2xy plus y square to the power of minus 3 all over 2, right? So therefore, note if we have 1 all over 3, so 1 all over 2 multiplied by 3 is the same thing as 3 all over 2. Simply means if you have 3 all over 2, you can simply turn it to 1 over 2 multiplied by 3. Because 3 multiplied by 1 will give you what? 3 all over your 2. It's all normal. So therefore 3 over 2, you can write it as 1 over 2 multiplied by 3. or 3 whole number multiplied by 1 over 2. It's all the same because 3 times 1 will give you 3 all over 2. They are all the same. So therefore, we can now change this one to be, if x du over dx minus y du over dy will be equal to, put your y square, which is our y square, then into 1 minus 2xy plus y square to the power of minus 1 over 2 cube, because this 3 will multiply this one to be 3 over 2. They are all the same. We just separate them because this 3 will multiply this one to be what? 3 over 2. So therefore, but we know our u is equal to, open bracket, 1 minus 2xy plus y square to the power of minus 1 over 2, as we have in the question. You see, our u is equal to 1 minus 2xy plus y square to the power of minus 1 over 2. And they are common in this. You see, our u is equal to 1 2xy plus y square to the power of minus 1 over 2. So we can simply replace this value with our what? With this u. This value can be replaced with this u. So therefore now our x du over dx minus y du over dy will be equal to, put your y square, the whole of this bracket we say is equal to what? Is equal to this u. Therefore this will be u close bracket cube. Because don't forget, we have 1 minus 2xy plus y square to the power of minus 1 over 2. And also this u is equal to 1 minus 2xy plus y square to the power of minus 1 over 2. So simply we can replace this value with this u, and we replace it here. And this our cube is outside the bracket, so we put our cube outside the bracket. So now we see clearly our x du over dx minus y du over dy will be equal to what? Will be equal to y square u what? U cube, as we were asked to. And the question also was, if u is equal to 1 minus 2xy plus y squared to the power of minus 1 over 2, show x du over dx minus y du over dy is equal to x, y square u cube. And we have proved it here. Our x du over dx minus y du over dy is equal to y square u cube. So we are now moving to the next question. So we are now moving to the next question, which is question number 2. In question number 2, we said, if u is equal to exponential xyz, find the value of the following: del square u all over del y del z, and del cube u all over del x del y del z. So therefore, this is also very simple. Solution. The question said, if u is equal to exponential xyz, Roman number 1, find del square u all over del y del z. Okay, this is also very simple and direct if we pay attention. The first thing you will do is you differentiate your exponential value in respect to z. Therefore, this will be du over dz. We are differentiating u in respect to what? In respect to z. And this will be equal to what? Whenever you differentiate exponential value, you're going to have, as you have in your question. So first of all, we'll differentiate this exponential value, and then you will differentiate this xyz separately, because it's a chain rule of differentiation. So if we differentiate this exponential, we'll go as we have in our question, which is what? xyz. Then now multiply by differentiation in respect to what? Du in respect to z. Differentiation in respect to z of what? Of x, y, z. Right? Then now our du over dz will be equal to, we say if we differentiate this one, we got as we have it is, therefore this will be x, y, z. And now differentiation of x, y, z in respect to z, this z will automatically be 1, because this will be z to the power of 1 minus 1, which is equal to z to the power of 0, which is equals to 1. So therefore, this will be multiplied by what? Multiplied by xy only, because this one is already 1. If you will differentiate in respect to z, our z will be 1. So therefore, now our du over dz will be equal to, this will multiply this one to be xy to the power of xyz. So now our d square u over dy dz. If you say d square u dy over dz, we are going to differentiate the value we got here, which is what? Xy close bracket and what? And xyz, exponential xyz is the value we got in this one. So therefore, our del u over del z will be equal to differentiation of this. Or if you want, you can say del all over del y is equals to, del u over del z. You're going to differentiate the value you got in differentiation of u in respect to z in respect to y. Which value do we got in differentiation of u in respect to z? We got xy exponential xyz. You see, del u over del z, del u over del z. So therefore, we can just simply differentiate this value if you want to get del square u dy over dz. So therefore, we can say our del all over del y of del u, skip this, you may be confused, skip this one, focus on this, all over del z, right? So therefore, our del all over del u will be differentiation of what? What do we have in du over dz is this one. So therefore, this will be xy close bracket xyz. So as the one we did in our previous video, you will keep this one as it is, you will differentiate this one, and next you will differentiate this one and keep this as it is. Therefore, now our d over du of this will be what? Xy close bracket multiplied by differentiation, differentiation of what? Respect to what? Respect to y, du over dy of open bracket xyz close bracket, then plus. Now we'll keep this as it is, this one as it is. Therefore, this will be x, y, z, then du over dy over dy of x, y, close bracket. So therefore, this will be d over du, dy, is equals to, we say keep this one as it is, so this will be what? X, y. Then differentiation of exponential x, y, z in respect to y will be what? It's going to be, if we are differentiating respect to y, then y will not be among them because y will be 1. And 1 multiplied by anything will going to be that number. So therefore, y will be 1. So this will be open bracket x, z, close bracket, then x, y, z. This is chain rule of differentiation. Then plus, we say keep this one as it is, which will be x, y, z, multiplied by differentiation of x, y in respect to y. If we are differentiating in respect to y, this y will be 1. I proved this several times, which will be y to the power of 1 minus 1, y to the power of 0, which is equals to 1. So therefore, this will automatically be 1, which will going to be multiplied by open bracket x multiplied by 1. So now our del square all over del y del z, this one is equals to this. It's normal, don't forget it, because we are differentiating the differentiation we have from the previous video, which is this one. So don't forget it. Well, now the next thing is going to be del square is going to be del square del y over del z is equals to x times x will give you what? X square. So therefore, this will be x square y then z. Then put this your value x, y, z plus multiply by the what? Plus what? Multiply this value, which is what? X, y, z plus. We say this is what? Multiply by. This is what? This is 1. 1 multiplied by x is x. Don't forget, this 1 is a differentiation of this y. Differentiation of this y in respect to y will give us 1, which is this one. And now this 1 multiplied by this x will give us x. So therefore, this will just give you x. Exponential xyz, exponential xyz, they are common. So you can factor one of them, you can factor them out. Therefore, now our del square all over del y del z is equal to, factor this out to be x, y, z multiply by x square y z plus this x as our final answer. So you see, it's very explicit. The first thing you will do is you're going to differentiate your what? You are going to differentiate your z. You will differentiate your u in respect to z, and you are going to get your final answer as what? Xy exponential xyz. Because first of all, you differentiate this exponential value, and whenever you differentiate exponential value, you're going to have as you have in your questions, right? So if you differentiate this exponential value, you are going to have this. Then multiply by differentiation of the power only, which is xyz, in respect to what? In respect to z. And if you are differentiating xyz in respect to x, you are getting 1. The z will be 1. So if z is 1, therefore then that's why that means xy multiplied by 1, since we say z is going to be 1 as we prove it here. You see, the reason why x becomes 1 is x to the power of 1 minus 1, which will be x to the power of 0, which will be 1. So therefore, this will be xy multiplied by 1. And we say if we have du over dz is equals to exponential xyz multiplied by xy, which you said differentiation of xyz. Then now this xy will multiply this value to be du over dz is equals to xy exponential xyz as a differentiation of u in respect to z. Then now, if you want to get u differentiation square, what does differentiation square means? Twice differentiation. First differentiation is in respect to z, and the twice differentiation is in respect to y. I hope you understand. The first differentiation is in respect to x, and the now differentiation square means what? Twice differentiation. That means the second differentiation in respect to y. And we say the second differentiation in respect to y is going to be differentiation of the u in respect to z. And we say our differentiation of u in respect to z is what? Xy exponential xyz. So now if we differentiate this value, then this will be d over dy of xy to the power of what? Xyz, right? So therefore, now our del all over del y will be equals to differentiation of this will going to be turned into product rule. Therefore, this first of all we're going to keep this value as it is, which is what? Which is this one. We're going to keep this value as it is and differentiate this. You see xy as it is, differentiation in respect to y of exponential xyz. Then plus keep this as it is, which is what? Xyz, right? And differentiation of u, and sorry, and differentiation of xy in respect to what? In respect to y. In differentiation of this in respect to y, you are getting xz. Because if we are differentiating in respect to y, the y is going to be 1, right? Since y is 1, this is going to be 1 multiplied by xz, sorry. Therefore, you have your xz multiplied by the exponential value xyz. Then plus, you have your xyz multiplied by differentiation of xy in respect to y is going to be x multiplied by 1. Because this y is going to be 1 as we prove it here. Y to the power of 1 minus 1, which is y to the power of 0, and anything to the power of 0 is 1. So therefore, this x to be multiplied by 1. Then now, we are going to multiply these two brackets. X times x, we got our x square. Then you put your y and you put your z. Then multiply by xyz. Multiply by xy exponential xyz, sorry. Plus exponential xyz that we have here, which is exponential xyz. And 1 multiplied by x is what? Is x. Therefore, we have our x here. Then now exponential xyz, exponential xyz are common. So we factor them out, because if you multiply this xyz, exponential xyz with this bracket, it will give you back as we have here. We just simplify the bracket. So therefore, we factor this out to be exponential xyz multiplied by xy square yz, which is x square yz plus x. Because if you multiply this one with this 3, you are going to have this one. X square y z exponential. Again, if you multiply it with this x, you are going to have your exponential x. So therefore, del square over du dz is equals to exponential xyz x square y square z plus, sorry, x square y z plus what? Plus x. So now we are moving to the next one, which we said Roman number 2. Roman number 2. We said if u is equal to exponential xyz, find del cube u all over del y del z. This has the same procedure as the one we just did right now, The only difference between them is that in this case we have, sorry, I make a mistake. We have x here. We have the del cube of u all over del x, del y, del z. We'll follow for the same procedure as we did in the previous one. First of all, we'll differentiate the z. Then we're going to differentiate the z in respect to y, and we're going to differentiate the z dy in respect to x. So let's try it. So, solution. Now, first of all, we're going to differentiate our u in respect to z, as we did in the previous one. Of what? Of x, y, z. Differentiation of u in respect to z of exponential x, y, z will be du over the z will be equal to what? First of all, we'll differentiate this exponential value, which will be x, y, z, exponential x, y, z. Then multiply by differentiation of x, y, z, which will be what? Du over the z of x, y, z. Close bracket, right? So now if you differentiate this whole of this value in respect to z, the z automatically is going to be 1. As we said in differentiation, is power multiplied by the coefficient. The coefficient is 1. 1 times 1 is the same thing as 1. So therefore, to the power of 1 minus 1. This will be 1 multiplied by 1 minus 1 is to the power of 0. Anything to the power of 0 or any alphabet to the power of 0 is 1. Therefore, this will be 1 times 1, which is equals to 1. So automatically our z is equal to 1 here. So now our du over dz will be equal to exponential xyz multiplied by xy, because this z we say is equal to what? Is equal to 1. So therefore now our du over dz will be equal to xy multiplied by this value will be xy exponential xyz as our what? Du over dz. So now next d over dy, we're going to differentiate our value in respect to y now. So will be equal to what? Differentiation of du over dx. We are going to now differentiate the value we got in du over dx in respect to y. Therefore now over del dy of value we got here, which is what? Xy and what? Xyz. Then this will going to change to what? The product rule of differentiation. Now our del over del y will be what? Keep this as it is, which is x. Let's divide it here, which will be x, y, close bracket. Differentiation of this one will be what? In respect to y will going to be x. Differentiation of this in respect to y is going to be x, z. Because here we differentiate this one in respect to z, we got xy. Now if we differentiate in respect to y, we are getting xz. So therefore this will be xz, close bracket, to the power of, as it is, xyz. Then plus, keep this now as it is, xyz, and differentiate our value, which is what? Xy in respect to what? In respect to y. In respect to y. If you want, you can put du over dy or just prime. So therefore, and now our del over del y will be equals to x times x will give us what? X square. Then put your y and what? And z. Close bracket, to the power of exponential xyz, sorry, plus differentiation of y, differentiation of u in respect to y. Y is going to be 1. So therefore we have our xyz multiplied by x. By adding this together in a bracket, this will give us del square y, because it's a 2y differentiation. We are differentiating the differentiation of del du over dx. Du over dx is already differentiation, and we are differentiating it for the second time. So that's why we say differentiation square of y. So differentiation square all over differentiation of y and differentiation of z, because now we are differentiating the differentiation of z in respect to what? In respect to y. So we can put our u here. Multiply by what? X square y z exponential xyz plus, put this your exponential xyz x. By factoring this out, because they are common, you have your del square u all over del y del z of exponential xyz. Sorry, this is exponential xy. Let me write it clearly. Exponential xyz of your x square y and z plus x. So now for del u over, for del square u over del y del z, as we solved in the previous example, you see we will follow the same method. The only thing is that this one we have also del x and the del is cube. So now we are proceeding for the what? For the x. And for the x is going to be, don't forget with the final answer we got here, which is what? Del square u all over del y del z of exponential yz exponential xyz into x square yz plus x, close bracket. Then now we are going to move for the third differentiation, or the cube u, or you can just say del all over del x. Now we are differentiating in respect to x of what? Del square all over del y del z. Now what you have here, you are going to differentiate it in respect to x. So therefore this will be del all over del x of, what is our final answer? Our final answer is del xyz of what? X square yz plus x. As we did in the previous one, first of all we are going to keep this as it is and differentiate this one. Then next we are going to differentiate this one and keep this as it is. So therefore this will be del over del x is equal to, keep this one as it is, which is what? X square y z plus x, multiply by differentiation of this x. If we are differentiating in respect to x, therefore x is going to be 1. Then now we are going to leave with y and z. Because if we are differentiating in respect to y, we are left with x and z. If we are differentiating in respect to z, we are left with x and y. Now we are differentiating in respect to x, we are left with x and z. Therefore this will be what? This will be y z, because we are differentiating in respect to x, therefore x is going to be 1. Exponential x y z, right? Then plus, now we will keep this one, we will keep this as it is, which is what? Exponential x y z, because here we differentiate this one, we keep this as it is. Now we are going to keep this as it is and differentiate this one. Now we're going to be du over dx of x square y z plus x, close bracket. So now our del over del x will be equal to y multiplied by y. We have our x square already. Y multiplied by y is equals to y square. Z multiplied by z is equals to what? Z square. Then now xy multiplied by x. Don't forget we have plus here, this plus. Now this x multiplied by this yz is going to be x y z. We have done with this one. Put your exponential side, which is x y z. Then plus, put this as it is, which is what? X exponential x y z. Then differentiation of this in respect to x. First of all, differentiate x square in respect to x. X square differentiation is going to be what? X square, x multiplied by, don't confuse, x multiplied by 2. 2 multiplied by the coefficient, which is 1, is going to be 2x to the power of 2 minus 1, which will be 2x to the power of 1, or just leave it like this if you like. So therefore this will be open bracket 2x, keep your y and z, then plus x differentiation of x here is going to be what? Is going to be 1. So now we say differentiation of this x is what? Is 1, because we are differentiating in respect to what? We are differentiating in respect to x. So therefore this x is going to be 1. So now our del cube u all over del x del y del z will be equal to what? We have your x square y square z square. We have our x square y square z square, right? Then plus x y z, which we have here, exponential x y z plus exponential x y z, then multiply by this value, which is what? 2xyz plus 1. Okay, now by factoring the common value out, which is exponential xyz is common. You can factor it out. Now our del cube u all over del x del y del z will be equal to what? So will be equal to, open bracket, exponential x y z, because it's common from the both sides, so we factor one of them out. So open bracket, put your x square y square z square, then plus, we have x y z and we have 2xyz, so we are going to add them to be 3xyz, because this is xyz and this also 2xyz. So therefore 2xyz plus 1xyz is going to be 3xyz plus your 1, as we have here. As this is our final answer of s cube u to the all over d cube u all over dx dy dz. We just follow the same procedure as we have as we did for the previous one. The only thing is that for this one we added for the what? For the x. As you can see, we started from differentiation of x, when we got our final answer, then we differentiate our u in respect to the final answer we got in x. After we have done, we got the final answer, then again we differentiate our u. We differentiate our u in respect to x of the final answer we got in del square all over del y del z. When we got our final answer, then it becomes 3 times differentiation of u in respect to x, in respect to y, and in respect to z. So as I used to say, don't forget you can comment your question in your comment so that we can answer your question in the next video. So now we are moving to the last part of the question, which is question number 3. That says if z is equal to tan open bracket 3x plus 4y, differentiate z in respect to x and differentiate z in respect to y. This is very simple. It's not as complicated as the previous one. It's straightforward. You can just solve it directly. Therefore, number 3 says, so we see our question number 3, if z is equal to tan open bracket 3x plus 4y close brackets. Number 1 say find dz over dx. So let's start with our Roman number 1. Our dz over dx will be equal to, we said in our previous video, I told you the differentiation of tan is equal to what? Sec square. So therefore this will be what? Sec square of 3x plus 4y multiplied by the differentiation of this bracket only, multiplied by differentiation of z in respect to x of 3x plus 4y close bracket. So now our dz over dx will be equal to what? We have our sec square here. Sec square 3x plus 4y close bracket. Now the differentiation of 3x plus 4y in respect to x. First of all, this 4y is going to be 0 because we are differentiating our value in respect to x, and this 4y has nothing to do with x, so it's going to be 0. Then this will be multiplied by differentiation of 3x is 3 because we are going to subtract 1 from the x as it's going to the power of 0. Power of 0 multiplied by 1. So the power of 0 is going to be 1. Therefore, 3 multiplied by 1 is equal to 3. So this is going to be what? 3. Let's prove it for in case. We said 3x. 1, we have 1 here, right? 1 multiplied by 3 is going to be 3x to the power of minus 1. 0, right? This will be 3x multiplied by 1. Because 1 minus 1 is going to be 0. Then anything multiplied by 1 is equal to that number, which is 3. So therefore now this our 3 is going to multiply this our equation. So now our dz over dx is going to be 3 multiplied by this value is going to be 3 sec square open bracket 3x plus 4y. Then now we're moving for the Roman number 2. Roman number 2 says we should find a differentiation of what? We should find the differentiation of z in respect to y. Now the differentiation of z in respect to y, we already know our z is what? Tan 3x plus 4y. And we say differentiation of tan theta is what? Sec square. Sorry, differentiation of tan is sec square. So therefore this will be 3x plus 4y. We will differentiate our tan, multiply the value as it is, then multiply by the differentiation of this bracket only, which will be d what? Is going to be dz over dy. Now we are going to differentiate in respect to y because previously we differentiate in respect to x. So therefore this value is going to be open bracket 3x plus 4y. As we did before, if we are differentiating now in respect to y, our 3x is going to be 0 because it has nothing to do with y. So this will be sec square open bracket 3x plus 4y close bracket multiplied by differentiation of this 4y is going to be 4 as we did for 3x as is equal to 3. So therefore this is going to be 0 because it has nothing to do with y multiplied by 4. 4 multiplied by whole of this equation is going to be dz over dy is equal to 4 multiplied by this equation is going to be 4 sec square open bracket 3x plus 4y as our final answer. So this is the end of the video we started today. Please don't forget to like and subscribe to this channel for more videos. And if you have any question, don't forget to comment in the comment button so that we can understand your question and answer it for you in case in the next video. So I hope you understand number 1, which is say show dx over du. X du over dx minus y du over dy is equals to y square u cube. If u is equals to open bracket 1 minus 2xy plus what? Plus y square to the power of minus 1 all over 2. And with number 2, we say if u is equal to exponential x, y, z, find the value of the following. Number 1, del square u all over del y del z. Number 2, del cube u all over del x, del y, and del z. And we say number 3, if z is equal to term open bracket 3x plus 4y, find differentiation of x in respect to of z in respect to x, and differentiation of z in respect to y, which we solved just now in the example. So thank you for watching this video. Please don't forget to like and